Well, good morning and welcome to week 6. I cannot believe that we're 6 weeks into the school year and that we're already into the month of October this week, which is great. I'm so excited to continue to grow with you and to be able to create this kind of progress together through our first unit. Today's lesson is going to be on the idea of reflections versus rotations. So last week you looked at all the different types of transformations. And this week, we're going to kind of hone in on these two ideas. And hopefully, this will help you through the unit and give you a deeper understanding of what these two things are doing. Learning target. What is our goal for today? So by the end of this lesson, watching this video, you should be able to answer the statement that I can identify and explain the points of rotation, lines of reflection, and new object locations with specific coordinates on a graph. So not only are we going to be looking at points and lines and different locations, but we're going to kind of be looking at the graph part of this. How can we use that graph to help us rotate and reflect objects successfully where they need to be using the correct specific coordinates that are given to us? So again, our target is this, and hopefully by the end of the lesson, you'll be able to answer or be able to say this statement with some confidence. So think back. I like think backs because it gets you thinking. Once you can bring that knowledge from last week back to the forefront of your mind, it's going to help us kind of go through this unit. So there is a funny video that I kind of have linked here. So if you can go to the Summit Learning and open up the checkpoint and open up the lesson plan in that checkpoint. So it'd be week 6. Under the engage section, there is 2 spots for you to fill in your own words. How can you explain what a rotation is versus a reflection? Take some time to watch the funny video. I like to kind of sometimes put this in just to kind of lighten the mood a little bit and kind of get you into the math unit in a different way. But take a minute here and write down or type down in that box right there the difference between a rotation and reflection based off what you remember from last week. So go ahead. Well, hopefully you're able to write down some information and some reflection and understand what's going on. So again, we have the idea of rotation versus reflection. So the idea of rotation is something that is rotating, or we said maybe turning around a central location. So there's that, we said point of rotation. There's that central point that object is turning around the same way until it gets back to its original spot. A reflection is something that's flipping across a line, right? So again, it can be one of the axes, it can be just a random diagonal, or anything else in between, but it's simply flipping across the line. A rotation is moving a certain amount of degrees around a point. So again, if you're able to write some things down, that's great. If not, maybe now's the time, after we've kind of talked about it now, to write down, jot some ideas in that section to help you remember these 2 ideas. So kind of moving forward, we said we're going to kind of look at the graph as a whole and how we can use this to help us rotate and reflect successfully. And I think it's important to know this. And you might already know this, which is fantastic. But I kind of wanted to run through it and see if you could just grasp a better idea of what a graph is. So in a graph, what we have is we have 4 quadrants, all right? And what we have 4 quadrants is, and my apologies, and I need to make a note of this. This, just realized that this is quadrant 2 and this is quadrant 4. So don't take, did realize I did it. So that is quadrant 2 on the left and quadrant 4 is the bottom right. So it kind of goes, we're kind of going from 1 to the left, down to 3, and then to the right to 4, and then back up to 1. So that's 1 to 4. But in quadrant 1, what we say is when we do a coordinate, right, we have a coordinate, right? If I write out a coordinate, and we've seen them before, all right, for an example, if I have something like 3, 1, all right? The 3 is what we call the x, right? That's where you're going to go across the x-axis, and 1 is up and down on y. So if I looked at this coordinate, I would say, okay, I'm going to go 1, 2, 3, and then up 1. So my dot's going to be right there. So I go we call it run 3 and rise 1. So again, the first part of the coordinate is the x value, the second is the y. So when we look at these plus and negatives on this graph, it's going to kind of help us. So in quadrant 1, both the x and the y are positive. So again, my example, both of them are positive. If they're both positive, they'll be found in quadrant 1. All right, if we move to quadrant 2, the x value is only negative. So if I made my 3 negative, I will come over this way 3 and up 1 to get my dot. So see how that dot has moved? And what we could say, that dot, those 2 dots that I just made, are reflections across the y-axis because I simply just changed the x coordinate, or the x value part of the coordinate, a negative. And if we look at quadrant 3, they're both negative, right? So anytime I go to the left on an x, like a number line, it's negative, and down, you always think down's negative. So quadrant 3, both of these would be negative. And then quadrant 4, the x value would be positive and the y value would be negative. So it's kind of a flip of quadrant 2 to be able to do in quadrant 4. The reason we're doing this is that it's going to help us reflect and help us rotate successfully, knowing full well the values or the signs that are corresponding to the numbers in each quadrant. If we know this idea, this is going to help us understand how to rotate and how to reflect successfully. So again, the 4 quadrants, again, show us positive and negative values that go with each number in each of these things. So to be able to understand this will help us reflect and do that successfully. So again, disregard my numbers. Quadrant 2 is at the top left and quadrant 4 is at the bottom right. So if I take this knowledge and move into, let's look at a reflection. All right, so let me get my pen out here. Actually, I need to erase from the previous slide. Okay, so if it kind of helps us, and sometimes it helps me as well, is I like to draw, okay, we got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. All right, so again, quadrant 1 is plus plus, quadrant 2 is negative plus, quadrant 3 is negative negative, 4 is positive negative. So again, it means we're using the coordinates x, y, all right, and then kind of establishing those signs based off where they are. So if we look at our first image and we want to reflect it, all right, say, I don't know, let's say that's reflected across the x-axis. So here's our x. We're going to reflect it across the x-axis, okay? If I look at this triangle, all right, I have a dot there, a dot there, and a dot there. Okay, now, first of all, let's find out what those coordinates are of that object. So if I look at the tippy top of that triangle, all right, and I move across, so we're going to call this A, B, and C. So if I look at dot A, all right, and I notice that I've moved 4 over and 1 down. So if I look at that coordinate for that triangle, what I get is 4, -1 for A. And if I look at B, I'm getting 1, 2, 3, 4, 5, 6 across, and I get 8 down. So I'm going to put 6, -8. And if I look at C, it's still going to be 8 down, but I'm only going 2 over to get to C. So it's actually 2, -8. And if I asked you to reflect this across the x-axis, if I do that, just think for a second, where will that triangle fall? Yes, if you thought quadrant 1, you are correct, right? So if I reflect across this x-axis here, it's going to be in quadrant 1. So using that knowledge, we can say, what are the signs in quadrant 1? Well, we know that both x and y are positive. So if we go over to the coordinates, all right, and we make both of those positive, and what I'm going to do is for Saroon, just get rid of this for a second, and I make both of these coordinates positive, all right? So again, we know that the first x is positive, but if I make the y positive, both of them positive, what it does is it's going to give me a new location for my reflection across the x-axis that shows the location of that new triangle. So if I go 4, 1, And then I go 2, 8, and 8. Based off the new coordinates that I established, it gives me a new reflected triangle. Now, that was a terrible drawing, but you get the picture. What it's going to do is help us understand how to find a new location to the reflection based off the coordinates. So if we know what quadrant it falls in, we can use the knowledge of the signs of that quadrant to change for the first set of coordinates that we have here and make new coordinates here to determine the new location of that triangle. All right, so the first step is finding the coordinates of the figure that you're given, all right, based off of its location. And then using the knowledge of what signs fall in each quadrant, so 1 is plus plus, 2 is negative plus, C is both, or 3 is both negative, we can make a new set of coordinates and change the signs based off of where it's going to be reflected into. So again, if I wanted to reflect it across the y-axis into quadrant, hopefully you remember, 3, all right, so I want to reflect it over here now. I would use my knowledge and say that quadrant 3 is negative, negative. So I come up here and I would change my coordinates to reflect that negative, negative. Okay, and what happens is that object, and I probably should just move this object here, gets reflected. Maybe it won't let me do it. Oh, nope. Stop it. Okay, it's not gonna let me do it. Okay, so what happens is we have a new triangle based off of this new location. So if we go -4, 1, right there's our dot, and we can make a new dot here, and we can make a new dot there. And there is our triangle. So no matter where it's reflected, we can take the original coordinates here and make new coordinates here because of what quadrant it falls in based off the signs that involves it with it. So again, 1 is plus plus, 2 is negative plus, 3 is negative negative, and 4 is positive negative. All right, so in reflection, we can use that information to determine the new location of that reflection. And hopefully that helped you in this section. So what we're going to do is we're actually going to move forward to rotation and kind of do the same thing there. Once I erase all of this and lovely information that we have. Awesome. Okay. So if you move to a rotation, once I get my mouse here, bam, rotation, we're going to keep the same quadrants. Okay, we got 3 and 4. And if I ask you that the central location, so there is our point of reflection, is 0, 0. And I want you to rotate it, okay? I want you to be able to rotate this 90 degrees, all right, clockwise. So first of all, we got to think out what is 90 degrees? Well, we know that 90 degrees is a fourth of its original position. So if I go 90 degrees, I'm only moving 1/4, right? If I go 180, and if I say you're standing straight up and I tell you to jump 180, well, if you jump 180, you're literally just jumping and facing the opposite direction. So you've moved half, right? If I said move 360, you do a complete circle and come back to the original position, all right? So that's 100%, that's full. So if we just move 90, not half of 1/2 is 1/4. And if we move 270, all right, that's another fourth added on to a half, it gives us 3/4. So we have degrees such as 90, 180, 270, all right, they're going to help us understand where we need to go. So if I said to move 90, or sorry, rotate 90 degrees, okay, clockwise. That means if I go clockwise, clockwise is going to go like this, like a clock. That means it's going to fall in quadrant 3, right? So it's going to fall in here. If I move 1/4 of position over to clockwise, that means my triangle is going to move here. If I said move 180, what quadrant do you think the triangle would fall in? Correct. It would fall in quadrant 2. It would keep moving around. And then 270 would be in quadrant 1, moving clockwise. If we moved counterclockwise, it would just go in the other direction. So we can use this knowledge to determine what quadrant it falls in to be able to use those positive and negative signs to change, all right, the coordinates to be able to make it rotate successfully where it needs to rotate. So if I look at this first figure, okay, if I look at this first figure, what were the coordinates of this first figure? And hopefully we can establish what they were. Well, if we look at them, we knew they were what? I think they were 4. Oh, they were 4, -1. Okay, they were 2, -8. And I think it was 4, -8. So again, nuke our coordinates to the triangle to be able to help us be able to rotate that successfully where it needs to go. So how are we going to do this if we say to rotate it 90 degrees clockwise, which again will give us a location, all right, where it needs to go, but it helps us understand that it's going to fall in quadrant 3. And if we remember quadrant 3, we know that it's negative. All right. So if we go up to our figure to the left, okay, and we notice the first thing that we have to do, and what makes a rotation different from a reflection, is that a rotation, a reflection, all we do is when we know what quadrant it's in, we just designate the sign, right? So if I was reflecting this triangle across the y-axis to quadrant 3, I would go up to the quadrant and I would change the signs to negative to match what that quadrant is. The only difference with a rotation is before I do that, I actually need to flip these numbers, okay? So I need to make the y the x, all right, and the x the y. So I'm actually changing 4, -1 to -1, 4. And then I'm changing 2, -8 to -8, 2. It's because with a rotation, because we're turning and we're only going 1/4 of a direction, those quadrants will flip. And the next rotation I make makes them flip again. So every time you rotate the figure, you are flipping the coordinates. So when I do this, the next step then is to say, well, the quadrant 3 that it's going to fall in is still negative. So I still need to make both of these negative. All right. The only difference with our rotation is that I'm going to flip the numbers or flip the coordinates. The x's become the y's now, and the y's become the x's. So when I go over here to make this new triangle, I'm going to say, okay, -1, I'm going to go down 4. And again, excuse me for my drawing with my finger. I'm going to go over -8, down 2. And I'm going to go over -8 and down 4. Maybe I can get that first one. 1, 2, 3, 4, 5, 6. That's what it was. Excuse me for that. It was 6. I didn't think 4 sounded right. So those numbers should have been 6. Again, even teachers get things wrong. Is 6. So if I come over 8 and go down 6, I think that's what I want to do. I get, oh, that's a terrible triangle. I get my rotated, oh my word. I get my rotated triangle. All right. So I get this rotated triangle that's found in quadrant 3 because of two things. I flipped the coordinate, all right, first, and then went up to the top and gave them both negatives to establish the quadrant that they were in. This will give me a successful rotation of that object. But the idea to know, the idea of 90 degrees, it goes 1/4 of a rotation. 180 is a half, and be able to determine what quadrant it falls in will help you understand what you need to do. And again, in the Explore section, there's some more resources that give you an idea of what this is about. But again, a reflection, all right, is just changing the sign of the quadrant that it falls in. A rotation needs to flip the quadrant first and then put the sign that it needs to be able to understand of what rotation that it made. So hopefully that makes sense, and hopefully you're able to take something away from this and be able to use that through your unit this week. Okay, so as we move on, I'm going to erase this first. And again, first thing I want to come up with some real world examples. Some real world examples would be, with rotation. I kind of came up with a fan, right? A fan has three objects. If you look over there, it has three objects that are similar, that are being rotated in a continuous fashion. So as that happens, we're able to get blown air at us, especially during the summer months that it's very hot and it kind of cools us down. But if you notice, the objects are the same, but they're in a continuous rotation, creating that air for us. And then again, a reflection is simple. It's a mirror. We use our mirror to be able to reflect our faces, to be able to see what's going there, to be able to change different things. But we use that mirror to be able to reflect to us. Now, you ever notice when you're in a mirror, all right, when you put this arm up, this hand up to this ear in a mirror, it looks like it's on this side, because again, it's just that reflection of you across that mirror line. Again, it's an actual mirror. But again, it helps us see things, especially when we're getting ready in the morning and we're trying to, guys trying to shave or whatever we're trying to do. That mirror, that reflection kind of helps us be able to do that. So these are just some real world examples to be able to understand the idea of these two objects and what we can do there in that way. And again, I like to have real world examples to kind of see how these things are applied in real life. So again, what's next for you? Well, if you're in the lesson plan, hopefully you can go through that Explore section. There's some more resources on this idea of rotation and reflection. And what I want you to do is share your thoughts in the Padlet under Explain. We did one last week. This is a chance for you to kind of reflect on what we've learned. Next thing is complete checkpoint rotation or reflection. All right, so again, this unit or this lesson has been on these two ideas. So I'd like for you to get under there and complete that checkpoint. The next thing is under Elaborate. I kind of created for you, Farmer Nate has crops, and when you get in there, you'll understand what I'm talking about. You're going to help Farmer Nate reflect and rotate his crops successfully. And in there, you will actually do a couple of things. And the instructions in your lesson plan are important. I've highlighted the important sections for you. All right, so you have to make a duplicate copy of the crop object on the graph twice using Control-D. And then you're going to take those objects and you're going to reflect and rotate them the way the scenario tells you to do so. And at the bottom of that Google Draw, that document, you're actually going to explain in your words how you came up with where it should go based off this video and whatever else you've learned through the resources or the checkpoints that you've done. So it's a chance for you to apply what you've learned in a real world scenario. So again, farmers sort of use this idea of rotating their crops. They may not necessarily reflect them, but they rotate them, that kind of help their land not dry out so much and help their crops grow successfully. So help Farmer Nate do exactly what he needs to do and make sure that you follow the highlighted directions in your lesson plan. And again, Last thing is reflect on this week's lesson under Express. It gives you a chance to kind of reflect, see what worked for you, maybe see what didn't, and be able to use that knowledge for the next week and next week's after that. So again, just want to kind of give you a rundown of where these again are found. They are found in the Summit Learning platform in the units. All right. So again, this week will be week 6 weekly instructional lesson. And when you click on that, it pops up a page like this where you click where the arrow is going, that link above where it says the title, and that'll take you directly to our lesson plan where you can begin to work on that and begin to enhance your knowledge. So guys, I wanted to kind of share this with you to kind of just give you some more direction on where that's found for those that are still confused. Remember, great job creating goals this week. Some of you still need to kind of work on that. Goals give you direction for the week, and it helps you see that week page all filled up and not just blank. So give yourself some goals, help yourself out, move forward, and then, it'll keep you on track. So the due date for this is October 7th. That is subject to change. That is next Monday. That is not going to be the due date. It will change. I'm not sure exactly. I'm thinking October 14th, just give you an extra week since we kind of were figuring the unit out the last couple weeks or so. So I'll give you till October 14th. But again, it's already October. If you have not started this unit, you need to get in there and start working on some of these checkpoints. And then watch the weekly videos because they are important. As you notice, I just taught you a key important idea with rotation and reflection. And every week I'm going to be doing that, sharing some important knowledge, teaching you some things that are going to help you work through this unit successfully. And then you need to start checkpoints and think on feedback. So if you haven't started checkpoints, all right, you need to get in there and at least attempt one. All right, watch last week's video and attempt the first checkpoint. Watch this video, attempt another checkpoint, and then keep it rolling. And for those that are still working and doing great, just keep going, think on the feedback, and do what you're supposed to need to do. Hopefully this has helped you, and I'm glad that you're able to watch this video. If you have any questions, you can send me a Hangout, email, or Zoom. Again, you guys are doing awesome. You guys are working forward in your unit. I'm excited to continue this process together. If you have any questions, you can let me know. Have a great week and keep focused.